Right. So the last time we were looking at the object-oriented design. Basically, we focus on the modeling of object-oriented analysis and also the design tools, which is actually what we have covered in our previous module as well. This is actually we are revisiting that so that you are comfortable with the major the concepts. Now, under that, we actually discuss uh, once you actually complete the object-oriented analysis, you should give what we call the object model, right, which should represent your information system. And then basically everything should be represented as objects and object-oriented concepts. Now, we discuss basic ideas of objects, how object look like, what are the parts. So basically we look at any object, we can have set of attributes, instance variables, and the methods. So those are the main things. And when you're creating the particular instance, for each of these attribute, we have set of values. So those are the ideas. And once you create a child object from the, let's say, the parent object, it inherits. That means, so all the attributes and the methods in parent will be available for child object as well. So when you create instance, so all the attributes and the method you have inherited from the parent will be available for the child object, and then you have to have values for those. Right. Now, attributes, basically we discuss that that will represent the what we call the information that we want to keep. We call sometimes data. So the data that you want to keep, we put it as under the attributes. So this will explain you exactly what information you want to keep for a particular object for other interactions. And then we have set of methods. So the methods also we have put it up, but each of these method we are going to do particular task. So which has several steps, and then we can list for any of the methods that we will use. So then we have messages, because the messages what we have discussed, I think at the end is depend on the interactions of the objects we can done through the message. So what will happen, for example, the message can actually affects differently for different objects. So for example, this diagram shows you when you say a message good night, different objects behave differently. So parent object will do maybe reading a bedtime story, and dog is go to sleep, and child is get ready to bed. So different objects get different meaning to different objects. So this is what we call the polymorphism. Right. Now, when you group the objects, we call them as classes. So objects in the classes, you will have same set of attributes and the methods. And then the objects in the class can also be grouped to subclasses, which we can call them as very specific within the class. So for example, one thing we have looked at last time is you can have a vehicle class, and then you can create several subclasses. In this particular example, you will see car, minivan, truck, and then school bus are defined as subclasses. So all the common attributes and the common methods are available for the subclasses you define or derived from class here. And then there can be very specific attributes or methods. They call uncommon attributes in this particular case, which you will see. Right. So once you put classes into more general category, we call it superclass. So you can see when you define a class employee, more generalized version of the class, we can say person, because employee is a person, right? And then we can have more specialized version, we can call instructor in this case. So the in this case, instructor is an employee, right? So similar to that, you can maintain this hierarchy. So then the middle one we known as the class. And then what is the generalized one is called superclass. Specialized one we call subclass. So always remember we have to interact with the superclass as well as subclass in object orientation. So understanding these different types of class is very important. Okay, now the next one is once you have understand the concepts that we have discussed as classes, objects, and then the instances. So how we can keep the relationships. So with the relationships among these different objects will help us for the communication and also help us to perform particular functions, right? So the relationship basically tell us what needs to know about different objects and how a particular object should respond and how the effects of the memberships, like the relationship that we have discussed, like whether you are a superclass or subclass, right? So the idea of inheritance we already discussed, which we used, is a child you can derive one or more attributes from the parent object. So this is the idea of inheritance. So when you have parent and you have a child which inherits all the parents' attributes and all the parents' methods, that's what we represent in this figure. So the first, uh, the tool that we have used is what we call the object relationship diagram, right? Um, so in this particular case, you can prepare what we call the relationship diagram. Sometimes we can relate it to these two ER diagram, but in ER diagram, we don't have any methods as such. So this can represent all the relationships in your information system. So which is we call object relationship diagram. So we have an example. Right. Now you can see in this one, all these rectangle objects with rounded corners basically shows you um, different objects and then different types of relationships among these objects. So you can see the first one as we have different types of employees. So we have superclass, subclass relationship can be seen. There are three types of employees you can see here. We have employee, we have under that employees manager, office staff, and instructor. So this is the superclass and these are the subclasses. That kind of a relationship, we call it is a relationship. Right. Now, the next one is this is about handling a gym. We have fitness classes. We have registration. We have schedule, and we have a student. Now, remember we discussed some of the ideas about how a student takes the fitness class. So for that, manager has to determine the class schedules, and you can list on open fitness classes where it will come to registration record. So here we have office members administrating the registration record, and instructor indicate the availability in the registration record. So once you have all this information, that actually adds into the fitness class, and then we have assigned the instructor to teach that particular fitness class, and the registration records adds the students, and then student can take the fitness class. So basically this is a very uh, high level overview of how object relationship diagrams looks like, right? So that will give you a main idea of presenting the different types of objects, the object hierarchy, something like we have a superclass subclass relationship. And then these are like very similar to ER diagram where we define what is the relationship with all these different ones together with this. Right. So we can see object-object relations. Right. Now, formally, when we want to represent this object-oriented diagram, the UML is the tool that we have used, which is very popular diagrammic tool we have used to documenting information system, right? So in this particular case, we can have, you know, you can have different type. Okay, using UML, you can actually come up with the different types of documents. We can identify use cases, use case diagrams, class diagrams, and sequence diagram, state transition diagrams, and activity diagram. So depend on our requirement, we might need different types of models that we need to develop for our information system. Right. Now, under this, we actually discuss use cases. So use case, one thing I want to discuss is the diagram that we have discussed or used to capture the behavior, right? So the main two things that we have in a use case diagram is you have actors where we will represent them as stick figures like this, and then user cases using ovals. Actually, you can put this inside if you want, because in this book it will put outside, but many of the book you will see that represent the inside, which represent the use case. The arrow indicates that this particular uh, person, right, interact with this particular use case. So that's what we are representing here. So, for example, here, three different actors, three different use cases, and then we represent the relationship. Right now, for example, passenger is making a airline reservation. Customer is placing an order. The bus dispatcher changes the pickup address. So usually in the information system, we want to capture the requirements of the system, the technical requirements, which we can have as different use cases. So that's how we can think of use case diagrams. Use cases here. So there are two types of relationships we can talk about in use cases. Uh, First of all, when an actor related to a particular use case, of course, we can use a single line. Simple line would do the job, right? But then you can have, extra information, things like users and include or extends. So these are the two common thing you will notice in a use case diagram. So if you say use users and include, if you use that, that relationship is, which means you need another use case by another to perform the task. So that is users and includes, right? And then we have extends. Then when you take extends, it's for example, in this particular case, you have alternative options in some cases, right? Now, for example, um, let's say in a library information system, right? Now, can you tell me what are the use cases that you can think of where you have include is there? The question is like, let's say we are developing a library management system, right? So what are the include relationships that you can find in a use case diagram? Yes, Nehan, Hatum, Nivandan, Sisiran. Can you give me an example in library management system where we can talk about include? Remember the include relationship, it's between two use cases. The idea that we want to highlight here is we need to perform the others. Okay, let me give an example now. In a library, let's say you are trying to borrow a book. So borrow books is a use case, right? So students try to borrow books, but before you borrow the books, we need to check two other, let's say two other use cases. One is you need to check whether there are any reserved book, or for example, whether the particular book is already reserved or not. Because on when the book is available only you can borrow, right? So that means borrow book use case includes another use case called, okay, you check whether this book is reserved, can say check reserved books. And then some cases, like let's say if you have a fine, then okay, library will not allow you to borrow books. So sometimes what might happen is borrow books can, you know, uh, include another use case, like they check whether you have any fine, right? So to execute a particular use case, if you need others, we will have include relationships. So that's the first thing that I want to discuss. Then extends. When you look at extends, it's different, right? That means, okay, alternative options. What are the other alternative options you have? Think about what are the alternative options. Yes. Can you give me an example from library information system? Ishan asked a good question. In the chat, he asked, can I say login is a use case? Yes. The answer. And forgot password is include relationship? Yes. Because in login, uh, can include another use case called forgot password. So Ishan, you correctly mentioned you have understood correctly the uses of include. So that is a correct answer. Okay, again, I will repeat my question for the audience now, like the borrow books that I have discussed. The two include use cases that I have discussed is when you want to borrow books, you check for whether the book is reserved. We can say uh, whether it's a reserved book, and you check whether there are any fines, right? If you have to satisfy these two user cases to borrow the book, so that's why we have include relationship. Now extend means you have alternative options. So what do you mean by alternative options? Yes. I will repeat the question again. Now, we discuss about the uses of include. Now I need you to think about the extents. So extend, I told you already, meaning like you can have alternative options. So for example, let's say, let me give you an example from for extend. Now, for example, let's say you want to search for a book. So that is a general search. Usual general search means you type some keywords and you get that. But then you can also have advanced search, which means like you can combine multiple keywords. You can have O and not logical operations. So, and then you can have filter, you can have information like author, publication year, genre, and so on. So basically, search for book is basically our base user case, and we can extend, which we call advanced search. So that is one example. Similar to do that, right? Um, we can also think about, um, let's say you are returning a book, and extents could be, let's say, okay, you calculate the fine. So that could be another, extend one. Okay, so one example again from Ishan. The library management system, checkout and return date and author info are user cases. Instead of say checkout is okay. Um, Return date and author info, maybe, yeah, you have to think about like how exactly you rephrase this. Um, and then you can include what information you can extend, right? Okay, so that's about different relationships we can have in a use case diagram. Now, here are some examples where we have users, student adds fitness class and product fitness class roster uses the results of add fitness class to generate a new fitness class roster. So it will uses another in this particular case. So to create use cases, to start with, you look at the information that you have gathered, and then you identify the main objective is to identify the actors and the functions or the transactions. So you have to come up with what we call use case description. So usually that could be something like this for each use case. In this particular case, we are uh, establishing here add new student use case. So the name is add new student. Actor is who's going to interact with this particular use case. It could be student or it could be a manager. The description you can have describe the process used to add student to a fitness class. And then successful completion, what will happen? So manager checks the schedule. Manager notifies student, fitness class is open, and student pays the fee. And then manager registered the student. Similar to that, you can also have alternatives. So manager can checks the class schedule for availability. Second one is like when you check it, the fitness class might be full. So then manager can notify it. Right. Then some preconditions. So to use this use case or execute this, first of all, student has to request for a fitness class. And then what happens after that, we call it post condition. Student is enrolled in the fitness class and fees have been paid, right? And finally, you can list any assumptions, and there's no assumption in this particular case. Right, here are the steps. So again, I have actually marked some of these scripts from last offering. And what I notice is some of the essential components are missing when you ask to draw a use case diagram. So the first one is you have to have system boundary. So boundary is a rectangle where we will normally show you what is belongs to this particular use case diagram. So you have to have a system boundary, which is a rectangle. And then when you are putting ovals, so you can place us in the diagram. So you can put it ovals. And then you can write down what all of these use cases are. And then you add the actors. So next you have to have the actors. So in this particular case, we have 3 actors. And finally, you will have relationships. So we indicate relationships in relationships as arrows. So the arrow indicate the relationship. So for example, in this particular case, this use case diagram represent the service department, hopefully is automobile. So it initiates with the first one with a request from the customer. And the user case that involve the customer first is create work order. So that involve another staff member, which is the service writer. He's the one who writes the order, which will happen to update another use case. So you will see an arrow which will update another use case, which call update work schedule, which should notify the mechanic. So once you have that, once the mechanic performs the work, we need to prepare the invoice, which again gets information from create work order. So it updates that. And then the service writer has to check. So this is very simple interaction of use case diagram. Next one is another example from the textbook where we are going to create a bus route, right? So in this one, we have a student which initiates a request. So create requirement forecast, which will inform or notify the dispatcher. And then dispatcher has to determine and prepare the route plan. And then you have to notify to staffing plan. So dispatcher again create that, and that will notify the driver. So in this one, again, it show you all the requirements as use cases. Right. This is a very interesting use case. I have put out the source here as well, which will give you idea about how in agile and other iterative processes, how you make use case diagrams. So this use case diagram represent a class registration. And you can see in the first release, you have only 2 actors and then only 4 use cases. So we have use cases view class schedule, add class, drop class, and view my classes. So in the release 1, we had only this. And then release 2, you have extend to get help, obtain help. So that's the use case. And for that, we have another staff member joining is the operator. So you can notice here that you can clearly see different requirements and hierarchies. Third one, it's a separate one. We have created between 2 actors, time and school account. So payment of fees we see included with the next release. So you can see when you're doing in agile process iterative one, you can keep on updating the design, right? And at the end you will have the complete design, but before that you will not, right? You don't have a complete understanding about how this works, not like in structured algorithms, right? Okay, so in this example, you will notice couple of ideas. Again, this is I have taken from another book from Dennis, Wixom and Roth. So in this one, we include the 2 things. Remember, we talk about include and then exclude. For example, here you can see make a new customer offer, which includes the create new customer, right? So similar to that, we have a couple of another include record sale contract, which includes the manage offers. Another accept or reject offer again includes in the manage offers. So then the next one is the extend. That means alternative options. So for example, we can have update custom information, which extends that to make custom offer, similar to make payment arrangements, which will extend to make offers, and so on. Right. And apart from that, okay, let's continue our discussion. The next part is once you have the use case diagram, for the selected use case, you can draw a class diagrams, right? So the class diagrams, what we have is we have object classes, their relationships in a particular use case. So to create the class diagram, we will, use the use case that we have developed, and then we need to identify what classes are uh, needed to represent any process. So the classes we have rectangle, usually we have a name in the top, and we are going to include two things, set of attributes as well as the methods. And then we normally connect all these classes with lines. Basically, lines represent your relationship. Then you can put the labels. So actions, that means how they relate to two classes. And then also you can have instances of one class is related to instead of another class by specifying cardinality. That means you can specify whether it's one-to-one relationship, one-to-many, or many-to-many relationship. That information you can keep. Right. So that's about the class diagram. So basically, class diagram represent how the objects are oriented. So which you can use to develop the system. Right. Now about the cardinality, there are different representation people are using, but here I'm going to specify how how UML notations are used. Remember, I think you have already done the one-to-one, one-to-many, and many-to-many relationship ER, but the UML notation is slightly different. So for example, in UML notation, when you have a 0 and a star, what it means is 0 or more. So for example, if you take a particular employee, so that could be have uh, one or no deduction, or there could be many deductions. So that's what it represents, 0 or more. Similar to that, employee and a spouse, again, you can have 0 and maximum of 1, right? So you can have no spouse or a one spouse, so that's maximum. So to represent 0, 1, so we'll use this representation 0, 2 dots and 1. Then if you just have a 1, what it means, you have one-to-one relationship. Then if you have one-to-many relationship, you have 1 with a string. So that's how we can represent the cardinality. Right. Now let's look at some example of class diagram. Again, as I told you earlier, this could be the starting point. You can start from a particular use case, and then that can be converted into a class diagram like this. And then when you have a class diagram, then this could be used for your development purpose, because these can be directly converted into classes in your codes. Right now here, you can observe that there are several classes related to each other. We have sales manager, sales rep, sales office, customer, order, and then items ordered are there. So if you look at the relations, you can have, for example, here, order, you have items. So for example, there could be what items are ordered. You can have in a order, you can at least have one or more. But item, if you look at the items per se, if you look at that, that might be included in no orders or maybe in multiple. So that's why it says 0 or more, right? Similar to that, so orders and customers. So customers are placing orders, and then customers can places again 0 or more orders. So some customers may not place order at all. But if you take up a particular order, definitely we have to have exactly one customer. So that's what it means. So in this particular case, we are assuming the order is actually placed by a single customer. Then you can look at here. So the customers are assigned to sales reps. So which means a particular customer will get exactly one sales rep. But the sales rep side, you will get one or more, 0 or more. So that means there might be some sales reps without any customer signed, or you have assigned many. And then the sales reps is assigned to sales officers. And then again here, when you have a sales rep, will assign to exactly one sales office. The sales office might have 0 more sales reps. And sales office managers, sales manager. So basically you have one manager, and manager will have one office, and the manager will manage the sales reps. So sales rep will be managed by a one sales manager, whereas you can actually this you can say under a single manager, you can have 0 or more sales reps. So that's how you can actually represent information in the class diagram. Right. Any questions on this? No questions? I hope you are clear about this. So we will have group work on Monday, where we can actually work on this. By the way, before we go into that, let me break for some time. I hope you are now very familiar with coming up with the user diagrams, class diagrams like this. Remember, the next thing that you need to practice is, given a class diagram, come up with the actual coding based on this. So I hope we are going to have a separate session. So I'm not going to discuss about the coding here, but in our interactive sessions, let's have an assignment which cover everything. But for the time being, let me present a few more examples from different textbooks, because you will see there are slight differences of variations of what we use for. Now, for example, this is this UML diagram is actually from famous database systems, textbooks by Elmasri and Nawate. And remember, in that, you can notice there are few classes. We have employee and we have department. And employees works for department. So particular employee can works only for one department. So this notation is slightly different from what we have discussed. According to the book's notation, this should be one, but that's what this book has used. So since we have discussed one there, So this should be changed according to that. And then the department can have, here it says 4 or more. Normally we will have um, 0 more or 1 or more. So in this particular case, if assuming that you have to have at least 1, so maybe we can have 1 or more here. But in some representations, as you can see, according to this representation, it means that at least you have to have 4 employees in a particular department. So that's how they have, put up this notation. Right. Then some employees works as managers. So that's what this relation means. And then in this one, you can see here an employee uh, works as managers. 0, 1 in this particular case, the reason is the maximum value will be 1, right? And then when you take a department definitely have to have 1 employee. So this is representing exactly 1 here. Right. Similar to that, so department controls some projects. So here we have projects. So you can see here the department, uh, uh, controls 1 or more, or in this particular case, I guess, more projects. And then project is controlled exactly by 1 department. So that's what this relation is about. And then employees works for projects. So that's what we use, see, works on projects. And then we keep track of number of hours particular employee works for a project. And you can see here employee is worked for 1 or more projects. And the projects, you have 1 or more employees. So that's what it represent here. So here we have a very special case. We will have dependent classes are also represented. Dependent means without the existence of employee, there's no existence for the dependent class. So which represents here. And then we have what we call a recursive relationship also here, because some employees supervise the other employees. So we have 2 relations, supervisor and supervisee. When you say supervisor, can supervise 1 or more supervisees, but supervisees, you will have only 0, 1 supervisors, which indicates that some, they don't have any supervisors. So this is the, this particular class diagram represents. And of course, this location is actually a multi-valued attribute at that time. So that's what it connects to both the, department and the projects, which indicates that this will have, multiple values. So you see, that's what it represent here, right? Another example, again, in this one, you can see superclass, subclass relations. Now, for example, here we have a bank account, and then there are 2 subclasses. Then we have current account and savings account. So you can see these are attributes and the methods. So, so all information is included here as well. So that is the addition of other things that we have discussed so far. Similar to this one also have particularly for superclass subclass relationship. So this is again I actually taken from the Dennis and Wixom's and Roth's book. So you can see here the person, it can be classified as employees and the customers, and the customers actually makes the offers. So similar to that, employee can further classified as shop mechanic and the salesperson, and the salesperson writes the offers, right? And then both shop mechanic and the sales person will be both this will be the part of customer service team. If you remember this relationship, I have actually represent this. So whole and part you normally say, so that several parts can make it to a whole. So similar to that, here we see the team comprises of several shop mechanics and salespersons. So that's what will be form the customer service team. So I think we discuss the major representations in the class diagrams. So it's up to you to study more and practice more, or we'll have separate interactive sessions to understand how to create, class diagrams in detail, especially starting from use case diagrams to class diagrams. For then we are going to actually capture the dynamic behavior of these objects. Any questions on this? No questions? Okay. So let me move to the next one then. In next one after this, these are sometimes we call static diagram, which will not capture the dynamic behavior uh, of the dynamic behavior in these diagrams. But the sequence diagram, these are known as what you call dynamic models. Basically, this will show you the interaction among the classes during the particular period of time. So sequence diagrams, usually we have lifelines, the messages, and the focuses. So lifeline means like this is represent the two different classes. We have class 1. Right? So here we have class 1 and class 2. Now this is called the lifeline, which indicates the timeline. And then this rectangle shape will indicate the focus. For example, there's a message going from class 1 to class 2, and then it will work it out this, and then you get the message 2, which indicates the end of the class 2. So similar to this, we can represent the information. Right. Now, information about the classes. So in here we know usually we have classes with rectangles. The names will be inside, and then you will have messages on the top of the sequence diagram. Then you will have lifelines, which identify by the dash line. So the lifeline represent the time during which the object above is able to interact with their objects in the use case. And X marks the end of the lifeline. So that also we have noticed earlier. Then messages. So messages identify a line which directions between the two objects, and the label shows the name of the message, and also it includes additional information. Focuses identify by the narrow vertical shape that covers the lifeline. The focus indicates when the object send or receive messages. So basically that will give you the information. Right. Now let's start with looking at a very small example from the textbook. So in this one, you will see the dynamic interaction among sales class, manager class, fitness class schedule, and the registration record. So all these are classes. And then what happens, student starts with the request in the business class. So that message passed to the manager. And then manager has to check the current schedule. So which actually goes to a schedule. So which will make the check. And if the class is free, whether we have free time slot, then we can notify back the students about that. We have, space you to join the class. So then student has to pay. Right. So once student pays, the manager will register the student, which will indicate here as well. So as you can see, so this will mark the end of registration, which is the dynamic behavior is actually shown. So this is important when you want to capture and also to work on different functions that you need to, make use of uh, to interact with the other, objects. Right. Let me give you some more examples. Again, the sources are given here. So in this one, actually, it shows you a shopping cart with customer, and then we have a shopping cart, order, and the item. Slight different, figures are used. In our case, actually, you can use the rectangle here as well to represent the customer. So the work start by creating the shopping cart, and then you have to get the total of the order. To get that, you have to first get the price of the item, and then you get the item price, and then you have to calculate the total, and then total price will be back to the shopping cart. So this will show you in how the shopping cart finding total of the bill value. Right. So with these two examples, I hope you got the basic idea of sequence diagram. Again, like I told you earlier, the point is we have to start by working on the class diagram, and then when you want to capture something, then you go to the sequence diagram. Right. Any question on this one? Okay, so let's move on to the next part. Uh, Next few slides, actually, what we want to discuss is Okay, right. Now, state transition diagram, usually we can represent the how the object actually change from one state to another. It actually depends on different events or the effects of the object. So the idea is um, we will start with one state and then you move on to another state, another state, and so on. So for example, if I take you in your case, our students, for example, uh, there will be a new students, then registered students, active students, then inactive students, and graduated students. You see the same object. Like if you take object student, can change from one place to all of the series of these transitions. So it's important to represent this graphically as well to understand, especially in the design stage. Right. So for example, let's look at one example here, which is about different states for accounts. So when you open up an account, the account status will be new account. And then once you make a deposit to your account, it becomes an active account. Right. Now, active accounts can be, you know, become a closed account by bank closing the account and customer closing the account. So those are the two lines you will see here. Or active one can be put into frozen, right? That means for some reason the accounts are frozen, and once they are done, you can release the assets. So this is how the state diagram shows you different state of an object. Right. Okay. So let's move on to the next one. The last one that we are going to discuss is about the activity diagram. So basically, activity diagram can be used to represent the order of the actions and also to identify these. So that's the idea. Hmm. Right. In this one, if you take an example, you can see the activities of this. So for example, in this example, it will show you the activities of interact with the ATM. So in this particular case, you see we will have the customer. This particular activity start with, you need to get the cash. So you have customer which insert the ATM card. And then when the card is accepted, then you have to provide the PIN. And once your PIN is accepted, then you can request cash. Now you can see two parts now, because now this will represent the different parts. In one part, if you have sufficient funds, then ATM can adjust the balance and you can get the cash. But let's say you don't have not sufficient funds, then we have to notify the customer, right? So that's how we can usually use activity diagrams. Right. Okay. So with that, we actually finish our discussing our object-oriented uh, modeling part of this. So we have discussed various diagrams. I think the next thing that you should practice is, uh, first of all, come up with these diagrams to represent before you really coding, to show your customer, your manager, and then the top management that your design. Once they are in agreement, then you can go for implementation. So implementation details, like last time, I'm not going to discuss in the class. Instead, we are going to have several interactive sessions to work on these things. Now, for example, now think of something like this, and the idea is, if you take something like this, you have to have an idea how to put this into a object-oriented coding. So ideally, by looking at the code, you know that everything is classes, right? So which means you have to have classes for items, you have to classes for class for order, and then you have to have class for shopping cart. That should be there. So these are the three different classes at least we need in this. And under that item, you need to understand what functions you need. Now, for example, in item, we have to have function, get function. The order, we have to have get total. These are the functions. And then order, we have to have calculate total. These functions should be there. So the idea is, you need to understand what values should be in each of these. Actually, given this, you should be able to come up with the class diagram and also the interaction. So for example, in this particular case, let's assume that you have a shopping cart. Ideally, what should happen is, we as a customer, we can create a shopping cart instance, right? And then we can we can add two items. Let's say you create a cart, you can create a cart object, and then you can add two items. And then when you use get total, should give us the total price, isn't it? So when you say get total, it should go through this, and it should give us the total price. So that's what I expect normally in the implementation. So the implementation details, as I discussed earlier, we'll discuss separately. So let's have the interaction sessions for those. And there we will discuss the implementation details this time. So the last time when we discussed, we didn't go through and look at how to put it into practice, but definitely this time you need to understand how to put this into practice. Right, guys, that's all what I have. We have a group work, which I will do interactively. So I'm going to postpone it to next week. So we'll meet next week on Tuesday. So I'll be there for this time, which we will go through what we have done so far on the class diagram. But I want to discuss how to put everything into other types of documents, sequence diagrams, and also the sequence diagrams and so on. So those things we'll discuss interactive in the class. Okay, that's all from me.